This is part 2 of lesson 4.3, solving systems by substitution. Continuing on with solving by substitution, in the previous problems we always had one of the equations that was y equals something or x equals something. And so when it's something like that, it's very easy to use substitution. When we have something like what we see in number 7, it's not quite as easy because I don't have anything that says x equals or y equals. So the question is, can you make one of those say x equals or y equals pretty easily? Look at the first equation. How hard would it be to get y by itself? If I just added a 4x to both sides, I would have y is equal to 4x plus 8. And then it looks just like the problems we just did. I would take this and put it in place of y. Now, the secret to this is when you substitute, you do not want to substitute it back in where it came from, because if you do that, since you're putting it right back where it came from, you're always going to get something like 5 equals 5 or 8 equals 8. So you have to put it in the other equation when you do that. So I'm going to write 5x minus 3 times, and instead of y, I'm going to write 4x plus 8 equals negative 3. And then you solve that equation. So remember how this works. 5x, the negative 3 gets distributed. And then I'm going to combine my like terms. I'm going to add 24 to both sides and divide both sides by negative 7. So that's my x. Now, that's part of my solution, but it's not all. So don't forget that you have to go back now, and now you have to find out what y is. So I'm going to write my ordered pair as negative 3 for x, and then I need to find what y is. So y is equal to 4 times negative 3 plus 8. So that's negative 12 plus 8. So that's negative 4. So my solution to the system is negative 3, negative 4. If I was to graph these two lines, that's the point they would cross. Okay, number 8. Look at your two equations. Which one could you easily make say x equals something or y equals something? So sometimes one of them is very obvious that you could just make one of them say x equals or y equals. So hopefully you're thinking about the first equation, and if you subtract 2y, you've got x is equal to negative 2y plus 5. And that was easy. So all I'm going to do is I'm going to take that and I'm going to put it in the other equation in place of x. So write it out, 2, and then instead of x, I'm going to put negative 2y plus 5. So that's 2x plus 4y equals 2. So now I'm going to distribute and solve. So negative 4y plus 10 plus 4y equals 2. What's going to happen to my 4y and negative 4y? They're gone. I'm left with 10 equals 2. That's never true. What that means is, remember we said that on the first page, that means no solution. That means that these two lines are parallel. So if I was graphing them, they would be parallel, and they would never intersect. And so no solution is my answer. I'm not going to have an ordered pair for this one. Okay, number 9 and number 10, I want you to pause the video. Try both of these. There's a couple good ways to do it. So just go ahead and try one of the ways and solve, and you're going to get your ordered pair for each of them, or no solution or infinite number of solutions. Okay, for number 9, I'm choosing to say x is equal to 2y minus 1, so I just added 2y on that second equation. You might have chosen to subtract 2x on the first one, and that's just fine. That will work just great. You would plug your y in to right there. Since I'm choosing differently, what I'm going to do instead is I'm going to take this as my x, and I'm going to plug it into the other equation for x. So 2 times x, and then plus y equals 3. So I'm going to have 2 times 2y, 2 times negative 1, plus y equals 3. So 4y plus y, and I'm going to add 2 to both sides, so 5y is equal to 5, which means y equals 1. So I'm going to put that in my 1, or in my y position. And then I need to take the y, and I'm going to find out what x is. So I put it in for y to find x. So x is equal to 2 times 1 minus 1. That's 2 minus 1 is 1. So my solution is the ordered pair 1, 1. Now keep in mind, and this goes back to when we were first solving with graphing, and we first talked about having solutions. I'm going to erase most of this so I can show you. But if I take my solution, and this is good to know if you're doing a test or a quiz or something, if you have this ordered pair, this is x, this is y, that means it has to work not just in one of those equations, but it has to work in both of the equations. So 2, taking the first one, that has to be a true statement. If it's not, my solution's wrong. Okay, that is a true statement. So let's try the second one. X minus 2 times 1 equals negative 1. That's 1 minus 2 equals negative 1. That's also true. So I know for a fact that that answer is correct. Okay, number 10, I'm going to choose to do plus 2y on both sides on the first equation. You could subtract 3x on both equations. You could do both of them. Let's do that. That would be interesting. So if I take or add the 2y, I would have for my first equation, x equals 0 plus 2y. For my second equation, I'll do this one in red. If I subtracted 3x, I'd have y equals negative 3x. So what I would do then is I could either take this and plug it in for x, or I could take this and plug it in for y. I'm not going to do both because I still have an x and a y. It doesn't matter which one, so I'll just do the one I have written down right there. So I've got this x equals negative 2 times negative 3x. So x equals negative 6x. So think about what you're saying. You're saying a number is equal to negative 6 times the same number. There's only one number that can happen for. You can add 6x to both sides. So you have 7x equals 0. Divide both sides by 7, and you get x is equal to 0 divided by 7 is 0. Now if I plug that in for x, or for x, I'm going to get y is equal to 0 also. So that means that my ordered pair, that's my solution, is 0, 0. That means those two lines are going to intersect at the origin. Let's make sure that's true. If I plug in 0 for x and 0 for y, is that equal to 0? Yes. 0 for x, 0 for y, is that equal to 0? Yes. So this is my solution. There's not going to be any other points where both of them work. You're finding the one point where they both work. Okay, number 11 and 12, go ahead and pause, come back, and check and make sure you got the right answers. For number 11, I solved the first one by subtracting 2 from both sides, and I got what was in purple right there. So purple one right there. And then on the other equation, I added 3x to both sides, and so that's what's in red, and I ended up with exactly the same equation. So I can continue on, but if they're exactly the same equation, that means that when I graph them, they're going to be exactly the same line, which means that they're going to have an infinite number of solutions. And so that's all I need to do. Okay, on number 12, I added x to both sides on the first equation. So I have y equals 2 plus x. I'm going to take that, plug it right in there for y. So I'll have 2x plus 2 plus x equals 8. Had my like terms. I have 3x plus 2 equals 8. I'm going to subtract 2. And so x is equal to 2. So in my ordered pair, x is going to be 2. I'm going to take that and plug it back in to find what y is. So y is equal to 2 plus 2, which is 4. So once you find one of them, it's really easy to find the other one. You just have to plug it back in and see what you get. Okay, this lesson will be continued in the third part.